So hello students, today we will discuss optimal binary search tree. Okay, so we know this tree. So tree is basically what? The tree is containing nodes and the edges. Okay, tree is basically a one hierarchical structure which does not contain any cycle. Okay, so guys, whenever we will talk about a binary search tree, then the elements are organized in some particular manner. Okay, it means the root element, whatever the element is present on the right hand side of the root element is basically a maximum element or greater than the root element, and whatever the element is present on left hand side is minimum element, means less than root element. This is the basic structure of binary search tree. Now what is about optimal binary search tree, which is called as OBST? Okay, so whenever we talked about optimal binary search tree, it means there are multiple search tree possible for particular key datas. Okay, and from that multiple binary search trees, one tree is basically called as a optimal binary search tree. Okay, now which tree is called as a optimal binary search tree, that we have to see. Okay, so basically see here we will get two arrays. Okay, one array is basically a key array. Okay, so key array is containing the data, okay, the node values, and there is a one more array which is frequency array. So frequency array is basically a frequency count. Okay, means how many times that key you want to search or that key you want to access. Okay, that is basically a frequency count. Okay, so see here where the frequency I is the number of searches for key I. Okay, means whatever the element is present in the keyth array or keys array at the ith index, in the frequency array on the ith index, the number of the frequency is given there. Okay, means there are two separate arrays. Okay, one array is holding the values, the key values, and second array which is frequency array which holding the number of searches or number of frequency. So now we have to construct a binary search tree of all the keys such that the total cost of the searches is small as possible. Okay, so guys, we will see with the help of example how we can draw the OBST. Okay, with the some data. Okay, where the key array is given and the frequency array is given. From that key array and frequency array, we'll try to draw one OBST. Okay, the cost of BST node is the level of that node multiplied by the frequency. So let us assume that if you draw one BST, now you want to find out what is the cost of that BST. Okay, so to calculate the cost of the BST, what you have to do? You have to multiply what? The level of that node and the multiply by its frequency. Okay, the level of root node is 1. Okay, so generally we consider the root as 0th level, but whenever we want to calculate the cost of OBST, we need to consider root is at first level. Okay, means let us assume that root is appearing 50 times. Okay, the frequency of the root element is 50. Then what we have to do? We have to multiply 50 by 1. Okay, because 50 is present, the root is present on the first level. Okay, so see here guys, example number 1. In this example number 1, the key array is given 10 and 12. Okay, means two elements are there. Okay, see guys, whenever we draw any BST, the sequence is important. But whenever such kind of a question we are getting where they are where they ask you to draw the OBST, in that case the sequence is not important. You can draw the tree whatever the sequence is given to you, and you can change that sequence also. I will tell you how to draw the OBST. Okay, but you have to satisfy the property of BST. Okay, that is binary search tree, means the right element is maximum element and the left element is the minimum element than the root. Okay, that property you have to satisfy always. Then guys, there is a one frequency array is given. So 34 and 50 is given here. 34 and 50. It means what? 10 is appearing 34 times and 12 is appearing 50 times. Okay. Now guys, you have to draw first of all the BST. So see, two elements are given here. So let us assume that 10 is appearing first. So we are drawing train here, then 12, then 12. So guys, 12 is greater than 10. That's why we'll write this 12 on the right hand side of this 10. Okay, so that's why we are getting this BST. Okay, this is one BST. But we cannot say that this BST is the OBST. Why? First of all, I need to calculate the cost of this BST. Okay, so let's see. 10 is appearing 34 times. Okay, so cost is 34 into 1. Why 1? Because 10 is at first level. 10 is at first level. 10 is the root element. That's why it is at first level. Then 12. 12 is appearing 50 times. 12 is appearing 50 times. So what I will do? Plus 50 into 2. Why 2? Because 12 is present on second level. So let's calculate guys whatever the value we are getting here. 34 into 1 that is 34 and 50 into 2 that is 100. Okay, so 100 plus 34 that is 134. Okay, so the cost of this tree, okay, the cost of this tree is 134. Now guys, let us assume that the key elements are 12, 10. Okay, now we are considering the sequence 12, 10. So 12 is appearing first. So 12 we are drawing here. Okay, then 10 is appearing. Okay, so 10 is less than 12. So definitely 10 is present on the left hand side of this 12. Why? Because this is the rule of BST, that is binary search tree. So now guys, here we are drawing 10. Okay, now let's see what is the cost of this tree. Okay, so this is the second tree which we got. What is the cost of this tree? Okay, so the cost of this tree is 1 into, what is the frequency of 12? 12 frequency is 50. Okay, plus 2 into, why 2? 2 is second level. So second level 10 is present. Okay, what is the frequency of 10? 10 frequency is 34. Okay, so 34 here. Now let's see what is the addition of these two. Okay, so 50 into 1 that is 50. Okay, and 34 into 2. 34 into 2 means what? 68. 34 into 2 is 68. Now add these two values. So you will get what? 118. Okay, so the cost of this tree, the second tree which we draw is 118. The cost of the first tree is 134 and the cost of the second tree is 118. So this second tree is called as what? OBST, optimal binary search tree. Okay, so see here everything is given. The cost of tree 1 is 34 into 1 plus 50 into 2 that is 134, and the cost of the tree 2 is 50 into 1 plus 34 into 2 is equals to 118. Okay, so 118 is the minimum value. That's why the second tree is called as a optimal binary search tree. Okay, I hope you are getting my point. So this is how you need to draw the multiple trees, and from the multiple trees you need to draw, or you need to find out which tree is a optimal binary search tree. See guys, here the key elements are given in the array. Okay, that's why guys we can change the sequence of the items. Okay, we can draw the multiple trees. Okay, but whenever you will get the question in exam to draw the BST and some items are given to you, in that case guys, sequence is very important. The first element is always a root element, and accordingly you have to put the second element, third element, fourth element, fifth element as per the properties of BST. Okay, that you have to remember. So let's discuss the example number 2 guys. So example number 2, they have given 3 key values. Okay, so here we have 3 key values, that is 10, 12, 20. and the frequency is given, that is 34, 8 and 50. Okay, so what we have to do? So first of all, we'll draw the all BST possible. Okay, all BST possible for this data. Okay, so first of all, we are considering 10. So we are drawing 10 here, then 10, after that 12. So 12 is greater than 12, 10. So 12 we are drawing here on the right hand side, and then 20. 20 is greater than 12. That's why we are drawing 20 here on the right hand side of the 12. So this is the first BST. This is the first BST. Okay, now the second BST. So let us assume that in the second BST we will get 12 first. Okay, so 12 first. So 12. After that 12, 20. So 20 is greater than 12. So 20 is here on the right hand side. And then after that 10. So 10 is less than 12. So 10 is present on the left hand side. Okay, so this is my BST2. This is my BST2. Okay, so let us assume that next 20 we are getting first. Okay, so 20 we are getting first. Okay, 20. After 20 we are getting 10. So 10 is less than 20. Yes, 10 is less than 20. So 10 is present on the left hand side of the 20. And then we are getting 12. So 12 means what? 12 means it is a greater than 10 and less than 20. Greater than 10 and less than 20. That's why it is present on the right hand side of the 10. Okay, so here we are getting 12. So this is my BST 2. This is my BST, sorry, this is my BST 3. This is my BST 3. Now guys, what we'll do, is there any other BST possible? Is there any other BST possible? Yes. After 10, let us assume that if we are getting 20, after 10, okay, so 10 we are getting first, after that we are getting 20. Okay, so after 10, if we are getting 20, then what will happen? Okay, so 10 and after that 20. So 20 is greater than 10. So 20 is present on the right hand side of the 10. And then after 20, we are getting 12. Okay, so guys, 12 is greater than 10 but less than 20. 12 is greater than 10 but less than 20. So guys, 12 is present on the left of 20. Okay, because 12 is greater than 10, okay, and less than 20. So 12 is present on left hand side of 20. So this is BST 4. Now guys, is there any other BST possible? Is there any other BST possible? Okay, so after 12, if we are getting 10, so 10, 20. Okay, so same BST2 we will get. Then guys, is there any other BST? Is there any other BST? So after 20, if I am getting 10, then 12. Okay, so which we already got. So let us assume that we will get 20, 12 and 10. Okay, so 20, 12 and 10. 20. Then after that we are getting 12. So 12. So 12 means less than 20 means on the left hand side of the 20. Okay. And then after 12 we are getting 10. 10 is less than 12. So it is present on left hand side of the 12. That is 10. Okay. So this is my BST 5. BST 5. Now guys, is there any other BST possible? Is there any other BST possible? You can try any other combination guys and try to draw the trees. Okay, if you are getting the same tree, no worries. You need to neglect that tree. But if you are getting a new tree, then you have to write that tree here. I don't think so guys, more than this is possible here. Okay, so guys, these are my 5 BSTs which I got. Okay, which I got. Now guys, I will calculate the cost of this BST. Okay, the cost of this BST. Okay, so first of all, I will write the frequencies of these nodes. Okay, so 10 we got 34 times. 34 here. Then 12 I got 8 times and 20 I got 50 times. Okay, so what is the cost of this? So 34 into 1 plus 8 into 2 plus 50 into 3. Okay, why? Because 20 is present on third level. Okay, that's why. Okay, so calculate the cost of this tree guys. 34 into 1, that is 34, plus 8 into 2, that is 16, 50 into 3, that is 150. Okay, what is the total here? What is the total here? 34 plus 16, that is 50. 50 plus 150, that is 200. Okay, so the cost of BST1 is 200. Okay, now let's see the cost of BST2. So 10 is 34 times, 12 is 8 times, and 20 is 50 times. Okay, now let's see. So 8 into 1 plus 34 into 2. Okay, because second level. Then plus 50 into 2. Okay, because second level. So let's see what is the total. 8 into 1, that is 8. 34 into 2, that is 68. And 50 into 2, that is 100. Okay, so 100 plus 68, that is 168. 168 plus 8, that is 176. So 176 is the cost of BST2. Now let's calculate the BST3 cost. BST3 cost. So 20 is 50 times, 10 is 34 times. Frequencies I am writing here 8. Okay, so 50 into 1. Okay, plus 34 into 2 plus 8 into 3. 8 into 3. Okay, so 50 into 1, that is 50, plus 34 into 2, that is 68, plus 8 into 3, that is 24. Okay, so what is the total here? So 8 plus 4, 12, 12 2, 1 6 7, 7 2 8 9, 9 plus 5 14. Okay, 142. So see guys, here we got a cost of BST3 is 142. Okay, which is minimum up till now. Okay, so BST1 is 200, BST2 is 176, and BST3 is 142, which is minimum up till now. We have to calculate the cost of BST4 and BST5 as well to compare which one is the optimal. Okay, so now come to BST4 guys. BST4, 10 is frequency 10, 34, frequency 20, 50, and frequency 8, 12, 8. So 34 into 1 plus 50 into 2 plus 8 into 3. Okay, so 34 into 1, that is 34, 50 into 2, that is 100, 8 into 3, that is 24. Okay, so guys, let's calculate what is the total here. 4 floor 8, then 3 to 5, and then 1. So 158 we are getting here. The cost of this BST4 is 158, which is greater than 142. Okay, now let's see the guys the cost of BST5. The BST5, just right here, what is the frequency of 20? 50. What is the frequency of 12? 8. And what is the frequency of 10 is 34. Okay, now let's draw. 50 into 1 plus 8 into 2 plus 34 into 3. Okay, so 50 into 1, that is 50, plus 8 into 2, that is 16, and plus 34 into 3. So 12, 1, 10, 102. 102. Okay, now calculate the sum of this. 102 plus 50, that is 152. 152 plus 16, that is 168. 168. Okay, so see guys, here we can clearly see that of BST3, which we draw earlier, is the having a minimum cost. So this BST3 is OBST. Okay, optimal binary search tree. Okay, so guys, you might get a question like this where they will ask what is meant by OBST. So you need to write the introduction of OBST, and you need to take one example. You can take any random example of 2 elements, 3 elements, and you can show how we can calculate the OBST. Okay, or they can directly give you one example and they will ask what is the draw the OBST. So in that case guys, you have to draw the BSTs. Okay, and then you have to check which tree is or which BST is the OBST. Okay, so I hope you are getting my point guys. This is what the solution